All right. So we're just going to talk about vectors this evening. We're going to mention just want to talk about the equation of a line, equation of a plane, how we find the dot product and cross product. So, and those type of things. So just the basic things first of all. So the vector notation. So if we have a vector that is in three-dimensional space, then it has it's in three-dimensional space, it has an x component, it has a y component, and it has a z component. So we usually talk about a vector as either the notation is we give the three components as x, y, and z, or xi plus yj plus zk. All right, so our vector, let us say that it's from O to A. So we write down OA is either as a three-dimensional component or in the ijk notation where I is x direction, j is y direction, and a is z direction. So there are some things that we need to talk about. I'll just use two-dimensional vectors, just mention some of the basic things. So if I'm so if I'm going from A to B, and let us say that OA is going to be 2, 3, and O to B is 3, 4. And I want to get from A to B. What do I write?
OB minus OA, sir.
Go on again.
OB minus OA.
OB minus OA. All right, let me just write it as AO, which is minus OA, plus OB. And I always say, I'm at A, and these are the roads that I want to get to B. So I go from A to O and then O to B, which is the same thing as O to A. In mathematics, when we're talking about vectors, is this switch it around, then we change the sign, plus OB. So that is going to be equal to, we change the sign and it has -2, -3, plus 3, 4. And that will be 1, 1. All right, so addition. All right, so the length of a vector Let me put it on a different page. We go to the next page.
Not yet, sir. Please.
Oh, no problem. Then when you're ready.
Respect, sir. Candidating.
All right. So the next thing that we want to talk about is length of a vector. Length of a vector is found using Pythagoras theorem. So in 2 dimension, it is you want the length of the vector. Let's call the vector or A. And let's say this is 3 and this is 4. So OA is 3, 4. Then the length of OA by Pythagoras theorem. A right angle triangle, the triangle is going to be 3 squared plus 4 squared, and that's 5. So the length and the modular sign indicates length. So for a vector in 3 dimension, then we'd use Pythagoras theorem in 3 dimension. So Pythagoras theorem in 3 dimension says that we square everything. So 16 and 9, 25 and 4, 29. Can't leave it like that. Third form. All right. So we want to talk about angle between two vectors. All right, so we want to find the angle between the two vectors. Then it is the relationship for the angle between the two vectors is, oh, sorry. We have to use what is called the dot product to find the angle between the two vectors. Then when we can,
Can move on now, sir. But that's for me.
Get one, sir.
all right, so the dot product, whoa, I this lane, so.
Siri, can I go? I'm gonna take a snapshot real quick. All right, sir, that's it. Respect.
All right, so we have to find the dot product first of all. So the dot product of the two vectors. By the way, I assume that I'm wasting your time with the preliminaries here. So
No, man, sir, we need him.
yeah,
Yeah, do a good job, sir. We need it.
never hear.
Sir, we need it, man, sir. Now waste your time, man.
Sir, refresh your memory, sir.
All right, so the dot product is the product of the x's, product of the y's. And if it's z, the product of the z. So now that is going to be 6 plus 12, which is 18. So the dot product is just multiply the x's, multiply the y values, multiply the z values if there's a z value. So the angle now is that we have a rule that says if we take the dot product, it's going to be equal to the length and the cosine of the angle theta. So now, so this dot product for in the case here, this is 18 is equal to the length of A, which is 2 squared plus 3 squared times the length of B, which is 3 squared plus 4 squared cosine theta. So 18 is equal to 4 and 9, 13, square root of 13 times 16 and 9 is 25. So therefore, cos theta, to make it the subject, is 18 divided by root 13 times root 25. So let's just work out that That's 18 divided by root 13
.091,
times
but approximately 1.
is equal to 0.099.
8
So theta is cos
inverse.
inverse of that, which is
0.9.
approximately 89 degrees. How much you get when you take the cos inverse?
So I'm gonna get 0.1.
Cos inverse is 0.99.
.10.
Where you get all of that?
Radians.
8. Oh, no
Do you know
degree, sir.
radians?
No, sir.
You know, my calculator in radians now.
So you want in a degree or radians?
You mean in degrees?
3.6. Or 3.624.
3.624.
Sir, 8
That's all right now.
8.11, sir. 8.11 degrees, sir.
Yes, sir. 8.11.
All right.
Sir, what calculator supposed to?
Degree.
I say what it in degrees.
Sir, me do it at 3.624 me get
We can use 0.998. If you use 0.99, you get the 8.1.
0.998.
Yes, sir.
Yes, sir. The figure is 0.99846.
Yeah. So we get 3.62.
Okay. So the
Yes, sir.
all right, close to zero. All right. So the relationship for finding the angle. So the other thing that we need to mention now is equation of a line, vector equation of a line. So to find the equation of a line, we need 2 points on the line. So let me take an example.
Sir, you could go back for me, sir.
All right, we just write down this. All right, so
All right, thank you very much, sir.
Questions, sir. In the
Mhm.
diagram, right? Is
Uh-huh.
I see line for A, O to A, and A to B. What is that straight line? OB?
One again. You see a line going
O
to
to
A,
A,
see a
yeah.
line going to
Is
B,
that O to B? The one that you
mhm,
just traced?
O to B,
Okay. Mm-hmm.
O to B, and the red line is, I'm going to say now, I want to find the equation of the line AB, a point X, any point on the line AB. So I want to be able to
Okay.
find any point on the line AB.
Okay. All right.
So if we make a little sketch, we want the line through AB. So we have O to A, we have O to B, and we want any point X on the line. So basically, what we're saying is that we want to find any point on the line OX. We want to be able to find any point on it. So now, I'm going to write OX initially. So O all right, so O to X. You'd agree with me that if I want to get from O to X, I'm at O, I'm here at O, and I want to get to X. Well, I'd have to travel on either A or B
Go to A
to
and
get
then
from
A to
O.
B.
All right. So just like you'll be telling your brethren, you call him and say, me there, O, want to reach a X. How me reach? So you there, O, take the A taxi. So you go from O to A. And then when you reach A, you go from A. You're going to leave from A to go to X. So them say travel, them would say travel along A, B until you see X. So how far must travel? We don't know, but you will see X when you reach it. But just go on the road AB. So what we're going to write is that it's going to be a parameter which we're going to call T, some factor. 2 times AB or 3 times AB or 4 times AB. This P is a parameter, a value. So it could be 3/4, it could be 2, it could be 10. All right. So what we're saying is go from O to A and then travel 10 miles along the road, going through AB until you reach X. So T is a parameter that we're going to use. So the vector equation of a line is always in that form. OA plus you see lambda, you see mu, you see T, you see all different things, but AB. So now what we need to find is AB. So this is the general form of the equation of our line. This is, by the way, this is the line that we want to find the equation. So AB is AO plus OB. So we want to get anywhere on the line that passes through A and B, then we have to get to the line. So we can use OB plus some lambda. If it is this direction, then it's going to be a negative parameter. But we have to get from O to A, and then A travel some distance along to find whatever point we want along the line. Any point on the line is some parameter times A, B. Yes, Mr. Strutt.
Yes, sir. So you said when we're traveling along AB, you said we're going from O to A.
Mm-hmm.
So why is it that how is that in the equation you have A to O?
No, you have to travel from O to
I'm
A.
talking about the bottom one.
All right. So
I'm talking about where you have A, B.
Right here.
Yes, there.
All right, because I need to find AB. I need to find, remember now, I said it's from O to A plus some value parameter times AB. So I need to find AB.
right.
I already have OA. So I'm going to fill in the numbers now. So A to B, I have to go from A to O and then O to B. All right. So I need to find this and I need to find this. OA and AB to find the equation of the line.
Good question, sir.
Mm-hmm.
But the thing is that X is beyond AB seen in the diagram.
Mm-hmm.
So isn't there B to X as well?
All right, so X is beyond AB. So for example, now what I'm going to say, let me just, for argument's sake, X is here. So this is X will be 2 times AB. So what we are saying is that the equation would be the OX is going to be equal to O, you go from O to A, and then you get 2 times AB. 2 times the distance A to B to find this point X. Right? So X is beyond AB, but it is in the same line as AB. So therefore it is the same vector. AX and AB, they are related in that they are parallel. These two are parallel. It's just that one of them is some value multiple of the other. So that is what we are saying is that any point on the line, you can find a value for the parameter t that we carry there. But so, and if I want to go, let's call this point y, then it is going to be some negative parameter. There's a -1. So you're going in the opposite direction. So what I'm interested to find out is that if I want to get to any point on the line, I know that I have to go from O to A, and then I have to go some direction AB. So if the thing is negative, then I know that I go in this direction. If it is positive, I know that I go in this direction. But every point on the line that I'm represented by this X can be anywhere on the line. Then I'm saying I'm going to multiply AB by some factor because AX and AB are parallel to each other, are collinear, are the same line, but one is a multiple of the other. So therefore, this T taking the multiple of AB. I don't know if I'm making sense. You understand what I'm saying? No? Say no so we can explain myself a little better. Or say yes if you understand.
Run it again, sir. Run it again. Go on again.
One more time, sir.
All right. The fundamental thing that we have to understand is that we want to find the equation of this line here. So we need, first of all, to get to the line. So any point on the line, and I'm calling any point on the line X. Any point on the line is X. To get, I need two reference points, which I'm calling A and B. So I need to get to the point X or I need to get to the point Y. Then what I'm saying is that I'll be starting at O. So I'm starting at O. So this is me, I'm at O. First thing, I have to get to the line. Agree? I have
Yes,
to
sir.
get to the line. So how do I get to the line? I can either go along O, A, or OB, but any one of those will take me to the line. Agreed?
True.
So I've reached the line. I've reached A, the point A. So think about this as a road. Now the point X that I want to go to. So you travel on the road, I reach A. Or you travel on the road, I reach B. But we're using A in our equation. So I travel on the road and reach A. I'm at A. What you going to tell me if I have to go to this arbitrary point X? And the only way that I will know that it's X is that you tell me, say, I see a big X. So I see a big X. The point that I want to go is just mark with a big X. What you going to tell me as an instruction now? We tell you, say, we take the thing and we reach a A. So what we must do now?
Travel straight to the CX one.
Travel straight where?
Along
Back to
AB.
O or travel with the empty direction? Along AB until we
Yes,
see
sir.
X.
Yes, sir.
So X can be anywhere. So suppose I'm traveling the whole of there and don't see X. What you going to tell me, sir? I say, I'm not see the X. I drive down the whole road and I not see X. What are you going to tell me?
Look further,
Suppose
travel to
X,
further.
all right? So suppose X was over here. What did I tell me?
Next
On back.
direction.
X is not here now. Traveling in the next direction, which in
along
vectors is
AB.
negative.
Yes, sir.
So what I'm getting at is that any point X on the line is going to, I'm at O and I need to get to X. Any point X on the line, I have to travel to A and travel some distance along the line, either in the positive direction or in the negative direction. So it's either in the positive direction or in the negative direction to reach that arbitrary point X. So that is what the equation is trying to, the equation of a line is trying to capture. The line, any point on the line, you go from O to A, and then you travel along A to B. We can tell you. So this parameter now is what we tell you how far you must travel. 2AB, 3AB, 4AB, 4.5, 6, 7, 9. So this is the parameter that determines everything in the equation. This T here. Or some people have it as lambda, some people have it as mu, whatever. So it is a factor. And if it is negative, then it's the opposite direction. So any point X along the line, any X anywhere can be represented. You go from O to A and then some multiple of AB. All right. So anywhere along the line, any X anywhere is going to be somewhere along the line AB. So you either go in the positive direction or the negative direction, you will end up at the point X, which is any point on the line. That's is what we're trying to capture with this equation. You go from O to A, so you're going from O to to the point X. That is what we're going to what's what we call R. So O to point X, anywhere on the line, you go from O to A, and then you travel along the line AB, and you must buck up on the point X. And if I tell you go 2 miles from O along AB, then you buck up the point X. Suppose it's 3 miles or 3, whatever the unit is. So any point can be represented. Just you will reach any point on the line as long as you know what the parameter is. And the parameter, let me use a driving analogy. T can say 2 miles. When you reach O, drive 2 miles and you reach X. Or X can be 3 miles, or X can be 4, or 5, or 6, or 10. Or if it is the other direction, it is -2, or -3, or -4, or -5, or so forth. So that is what the vector equation of a line supposed. So this thing that I have here, R equal OA plus TAB, is the equation of the line, the general equation of the line. So after that, I need to find OA and I need to find AB. Any clearer or still not make no sense?
Kind of clearer, sir. So we're going further on.
Kinda. All right.
Yes, sir.
All right. So now, let's worry about this to finish the problem. So AB is 3, -2, -2. So my equation is R is equal to OA, which is 2, 3, 4, plus T times 3, -2, -2. So any value I put in for T, it will carry me somewhere along the line. So the line is represented. Any value I put for T, it is going to carry me somewhere along the line. If I put T equal 1, then it's going to end up at B. If I put T equal 2, then it's going to end up 2 times the distance B. If I put T equal 3, if I put T equal -1, if I put T equal -1.5, any point along the line, I just put in the parameter T and I must end up somewhere on the line. So this is the representative of the equation of the line.
I get it now, sir. I get it. Honestly, I get it now. I see it.
Okay, good. So the general thing is just to write down the equation of the line. All right. Cross product. So we could just talk about physically how you find cross product. So physically how we find the cross product before we explain what it means. So that would be I, J, K, and we find that determinant. So if we use the same vector, 2, 3, 4, and 5, 1, 2, 2, 3, 4, 5, 1, 2. So that is I, times 3, 4, 1, 2 minus j, cross out the row and the column that the j is in, and that is going to be 2, 4, 5, 2 plus k, cross out the row and the column that the k is in. That's 2, 3, 5, 1. So that is I times 3 times 2 minus 4 times 1 minus j, 2 times 2 minus 5 times 4 plus k, 2 times 1 minus 5 times 3. 6 minus 4 is 2. 4 minus 20 is 16. So that's plus 16j. Plus 2 minus 15 is 13.
Sorry, why is it negative?
Oh, when we find the determinant with a 3 by 3, if we're working with the row and the column,
Sorry, sir. Yeah,
then it's plus minus plus. We start over there.
Sorry, sir.
Very sorry about thief money from me. Me need to know, you know.
No, sir.
You never thief no money from me. All right, so the cross product, whenever we find a cross product of two vectors, it gives a vector that is mutually perpendicular to both A and B. So it is perpendicular to A and is perpendicular to B. So mutually perpendicular to both A and B. So that is a nice segue to find the equation of a plane. And that is a nice point full stop where we're talking about finding the equation of a plane, because that is where we're going to pick up. And so on Monday, we're going to work a few problems concerning the equation of the plane. All right, so we're going to stop here for this evening. Crash course through vectors.
Quick question, sir.
Mm.
There was a question that I wanted to ask for a long time ago, but I keep on forgetting. There was a question that asked for eigenvalues when we were given a differential equation. The answer for the eigenvalues before using MATLAB, before asking for solving the differential equation, I was searching through the lecture, but I don't remember seeing anywhere where you taught us how to do it. You taught us how to solve differential equations using MATLAB, but and you taught us how to solve eigenvalues if you're already given a matrix. We don't know how to take from a differential equation to put in the form of a matrix to utilize it. So say for example,
Put the
so you have
differential equation.
yeah, so you have a differential equation of say for example 2d squared y over dx squared, or yeah, whatever one, plus 10 dy over dt plus 1. Sorry, plus y.
Plus 1?
Yeah.
Or plus
plus
1?
1y, which should be same thing as y, yeah. Which is equal to what was this form again? Which is equal to -2 sine 2t. -4 sine 2t. So -4 sine 2t. Yes, sir.
And what is that you
So
are
the question asks the question asks to find the eigenvalues of this system. Unless I wrote it down incorrectly, but that's what all right, just simply add it for the roots of the equation. Root of the auxiliary equation.
So the eigenvalues and the roots of the auxiliary equation are one and the same. So when so some persons just say find the eigenvalues, but it's the same as the roots of the characteristic equation or roots of the auxiliary equation. So you just solve 2k squared plus 3k plus 1 equals 0, and k would be whatever they work out k to be are the eigenvalues.
Well, in this case, it wouldn't be 0. Here in this case, it wouldn't be 0 because don't you have to still take into consideration the -4 sine 2t? Or will you still have to equate it to 0 despite having that?
You have to solve with 0 for the homogeneous equation.
Okay.
Or if you were to put it in the this u would be the -4 sine 2t. That would be the input. So the eigenvalues of this matrix would be the same as the solution to this equation. The system matrix.
Okay.
And the eigenvalues would be the same as the solution to your auxiliary equation. All right.
Okay. All right, thank you, sir.
All right, no problem. All right, so Monday. People are thinking Monday is a holiday again.
It can be a holiday if you want, nothing.
Nobody's all right. You know, I done the course.
I got done the
exam.
So we can do it today now, sir.
No one is all right.
Oh, by the way, sir,
Next
is it
week,
possible
Thursday.
for you to send us some past papers so we can practice some questions?
Yeah, I will do that, but the exam is going to be two multiple choice papers.
We know that, sir. We just want to practice. You know?
Yeah, when you say
Okay.
same class of project.
Are they here?
No, say it is a softball project last week, sir.
Yeah, I was going to give you one, but I thought it was a
Oh, so you just give it two tests
Monday.
in the project.
Yeah.
All right, sir.
All right. All right. So Monday.
Take care, sir.
All right, cool, sir.
Good morning, sir.
All right.
Yes, sir. Blessings, blessings.
All right.
All right, sir. Night, sir.
All right then.